Okay, this is once again a rational equation because we have variables in the bottom. We need to once again find our LCD, but to remember to find your LCD, you got to factor each denominator. The third denominator here is really differences of squares, so it factors into a 2x minus 3 and a 2x plus 3. Your LCD then is all the different things that are occurring in the bottom. Well, you have a 2x minus 3 occurring here and here. You also have a 2x plus 3 also occurring on the right and on the far left. So that is your LCD. Multiply each one of your three fractions here by your LCD, which ends up, because this is over 1, really it only affects the top. So you multiply each fraction by your LCD on the top. You'll notice then when you do that, we have stuff here already crossed out that drops. So to begin with, you only have your 2 and your 2x minus 3. Here your 2x minus 3 drops. Here you're only left with your plus 4 times your 2x plus 3. On the right-hand side, everything drops there for the bottom and what was afterwards, so you're only left with what was on the top before, your 5x plus 6. Distribute through on the left to get rid of all your parentheses. Combine your like terms on the left. Subtract 6 from both sides. Also, you'll notice you could subtract the 5x from both sides. Divide by your 7, and you get x to be 0. Now, you get x to be 0, but once again, you need to go back and check. Does taking 0 and plugging it in here into your initial denominators of here, here, or here cause you to get a 0 on the bottom? 2 times 0 plus 3 is not 0. 2 times 3 minus 3 is not 0. 0 squared times 4 minus 9 is also not 0. So 0 does work. If, however, if we had tried our answer and it did cause us to get a 0 in one of our denominators, then we would not be able to use that. Now, an identity is where every number in your domain is a solution. Well, basically, to show that this is an identity, we want to simplify the left-hand side down to see if we get what we have on the right. So on the right, we just still have our 6x squared minus 4. We want to work out the left side to see if it simplifies down to that. Well, let's go ahead and FOIL through here on the left side, our 3x times our 2x, our 3x times our 1, our negative 4 times our 2x, and our negative 4 times our 1. We also have this plus 5x afterwards. Collect your like terms here on the left. You'll still have your 6x squared. You have your 5x, your 3x, minus your 8x. They all drop. They cancel each other out, and you'd still have your minus 4 on the left. We want to see, is that what we have also on the right? Which it is. Since the left side simplified down to be what we had on the right side, this is an identity. Equivalent equations. Equivalent equations have the exact same solution. We want to say, or see, if what we have here on the left simplifies down to give you this. Because on the right, your answer is x equals 9 is what it ends up being. So the question is this end up having the same answer? Well, here on the left equation, we have two fractions that are equal. Both the bottoms are the same, and the fractions are equal, therefore the tops have to be equal. And so you get your tops being equal. When you solve that, you get x to be 9. So since we got a x equaling 9 here on the left, and your x being 9 over here, both having the same solution, we know they are equivalent equations. Well, here we need to go ahead and solve this equation for r. But let's first of all take a look at solving a simpler equation. Suppose you had this and you wanted to solve it for r. All you'd have to do then is to get rid of the timesing by 2 because that's the operation in front of r. So you use opposite operations and divide by 2. So right now up here, you have your pi being multiplied by, your r being multiplied by 2 pi. So all you'd want to do is basically divide by 2 pi on both sides. And so when you do that, on the right side, you just get your r by itself. On the left side, you get a c over 2 pi. Let's take a look at a simpler version of this one here, which you guys have seen before. If we wanted to solve this one for r, you'd want to get rid of this 12 that was right here by subtracting 12. Now, most of you would probably put a negative 5 here, but for the sake of this problem, I'm going to leave it as a 7 minus 12. Then you'd have to get rid of multiplying by this 12, so you divide both sides by 12. And so we would get something like this. Well, we'd want to do the same idea up here to be able to get r by itself. So you'd want to subtract your p from both sides. When you subtract your p from both sides, we end up getting this. You now want to finish getting r by itself. Right now, r is multiplied by your p and by your t, so let's divide both sides by your pt. And when we divide both sides by pt, then we get a minus p all over pt, which is equal to r. Well, let's go ahead and take a look at this one here. We want to solve it for h. You'll notice you have h in the parentheses. Two ways to do this, but one way that's fairly easy is to eliminate the parentheses so you don't have your h in parentheses, so distribute through your 2. Now, you're trying to solve it for h. So you want to try to get the h's on one side. Here we have our h's. This does not have an h, so you'd have to take it to the other side. So let's subtract a 2lw from both sides. So then we'd have a s minus a 2lw. Subtract it from the right side, it disappears because it gives you 0, and adding 0 doesn't change it. So we're left only with the highlighted stuff on the right-hand side. Now, you guys would be able to solve something like 5 is equal to a 7r. If you have it written as your variable times what you're trying to solve, or a number times with your variable you're trying to solve, and we'll change it to h here since we're trying to solve this one for h. You know you'd use opposite operations, and it didn't write, so just a sec. So to get rid of a number in front of your variable, all you have to do is divide, and that's what we're doing here, dividing both sides by 7 to give us this right here, which gets us h by itself. Well, is there a way we can write this so it's an h times something? Well, yes, all we really have to do is just basically factor out our h. If you pull your h out, you're going to be left with your 2w here. You're going to be left with your plus sign, and you'll be left with your 2l here, and that's a 2 times l, not a 21. Now, to get rid of your h times your parentheses, all you have to do is basically divide both sides by your parentheses. Well, when you do that, you get your h then to be this. S minus 2lw over 2w plus l is equal to h.